Assalamualaikum and good morning, everyone. Okay, today we are going to learn a new topic, new lecture. So last week we have learned about beam element, and this week we are going to learn about constant strain triangle or CST. Please be reminded that your due date for quiz beam is tonight. Okay, before 12 a.m. Okay, so before we can understand about what is constant strain triangle, let's go back to what is plane stress and plane strain. So a plane stress is when the state of stress, either normal stress or shear stresses, directed perpendicular to a plane are assumed to be zero. And this is usually applied for a body that is small in one direction or very thin, a very thin body, usually thin on the z direction, and the loading is applied only on the x and y direction and no loading on z direction. Another term is plane strain. So a plane strain is a state or condition when a strain that is normal to the xy plane and the shear strains gamma xz and gamma yz are assumed to be zero. And this is usually applied for a body that is very long, okay? A very long body, usually in the z direction, okay? A body that is long in the z direction with a constant cross-sectional area. And same with plane stress, the loading is only on x and y direction, but not in the z direction. So this is your first formula that you need to jot down. So principal stress is given by sigma max equals sigma x plus sigma y over 2 plus square root of sigma x minus sigma y over 2 squared plus tau xy squared. So sigma minimum, similar formula but negative, okay, minus. And the principal angle, tangent to theta p. So theta p is the principal angle, equals 2 times tau xy over sigma x minus sigma y. So these three formula, I think you have encountered this in solid mechanics, okay? Strength of materials, maybe related to Morse circle. But here, I think you will encounter this again in this lecture. So please jot down this. And then we go to understanding the stress-strain relationship. Okay, so we assume a linear relationship between stress and strain. So for plane stress, for a plane stress condition, the stress-strain relationship is given by sigma equals d times epsilon. So sigma is stress, epsilon is strain, and d is the like a constant, okay, linearity constant, or we call it a stiffness matrix, stiffness constant. And d for plane stress is given by E over 1 minus V squared times this matrix. So E is your Young modulus, So E Young modulus, and V is Poisson ratio. Okay, so when question gives you Young modulus and Poisson ratio, and what condition it gives, like for example plane stress condition, then you need to use this D. Okay, so this is another formula that you need to um, jot down. Okay, so please be reminded that in CST there are so many formulas, and actually throughout this lecture notes consists of derivation. Okay, deriving the formulas, which I think uh, most probably not coming out in test lah about derivation. So maybe throughout this lecture, I will skip some of the derivation and gives you only the important formula. Okay, so this is the formula for plane stress. And then for plane strain, same thing, but the formula for D is different. Okay, so this is also need to jot down. So this is for plane strain, and this is for plane stress. Okay, now let's go to our main topic, which is constant strain triangle. So consider a thin plate shown in the figure. So we apply a force in both direction, or traction force. So one going to the right and one going to the left. So basically we stretch the plate. Okay, so we can study this using finite element method by discretizing or making the plate into smaller element. For example, like maybe we can separate the plate into 4 triangles. Okay, by dividing the plate into 4 triangles. So this is usually you encountered in finite element method in software. Maybe you use Nastran. So you split up the plate using automatic mesh created by the software. So in this topic, constant strain triangle, we are going to learn how we can understand the process or understand the manual calculation on making the mesh and so on. So we can discretize the plate using triangular elements. So here it uses a smaller, okay, a smaller triangle compared to the one that I drawn earlier. So why here we choose triangular elements? So usually we can choose, there are a lot of elements for mesh. So we have triangle, we have also quadrilateral, okay, or square. So for 2D, so this is 2D cases, and it's also okay, a 2D case. So for 2D case, we use triangle or a square. But in this topic, we are going to focus on triangle. Okay, but maybe if you are interested to know about square element or quadrilateral element, you can read it by yourself. Okay, it's not going to cover in this course. So before we can understand how to calculate this the distribution of displacement on the plate, we need to do some um, naming, okay, or derivation first. So first, when we draw the triangle, we need to label the nodes or the points on the triangle. So how we can name this node? So the naming of this node is important for you when calculating the stiffness matrix later. So when you calculate the stiffness matrix, later on you will need to superpose or combine them when there are so many, when there are other elements, like when there is another triangle element or neighboring triangle element. So to name the nodes, we name it counterclockwise. Okay, for example, maybe this is node number 1, and then counterclockwise, the Following node is node J or node number 2. And then the next one, counterclockwise, is node M or node number 3. So in this triangular element, we use I, J, and M. Okay, so I, J, and M. Or you can name it 1, 2, 3. Either way is okay. As long as it is counterclockwise. Okay, counterclockwise, 1, 2, and 3. And we split the displacement of the node using the symbol U and V. So like in truss element or beam element, we use UX and UY. So because there are so many symbols that might confuse us with X and Y later. So in constant strain triangle, we use UX as U and UY as V, okay? U and V. Because later we need to consider the coordinate as well, coordinate of the nodes. So the coordinate is using X and Y. So we don't want to confuse X and Y of the coordinate and the X and Y of the displacement. So because of that, we use U and V. So our displacement for the constant strain triangle, for this one triangle, now there are 6 degree of freedom. So one triangle now has 6 degree of freedom. Each of this displacement represent the displacement of X and Y direction for each of the node on the triangle. Okay, so this is something that you need to remember by heart. Okay, for constant strain triangle, you have 6 displacement. Okay, I skip things that I think not important for you. So if you think that I didn't explain things that maybe you need explanation, please let me know. Okay, so what happened here is that we can, similar to beam element, we also have displacement function in constant strain triangle. Okay, so the displacement function depends on the X and Y coordinates, okay? But in the end, the important formula that you need to remember is this formula. So how to find the area of triangle. So let's say if you are given a triangle that is irregular in shape, let's say and a triangle that is irregular in shape that you cannot calculate the area directly, so you need to use this formula. Okay, so X and Y here represent the coordinate of nodes, okay, of each node. But most of the time the triangle given to you will be a tegak one, okay, a straight one. Like for example, let's say you have this is length 2 and the height here 2 as well. So you can calculate the area without using the matrix formula. Okay. So for example here, the triangle given here. So you can split this into 1, 1. So the left side area is 2 times 1 times half. So you get 1. And the other side is same, okay, half equals 1, okay. So you can combine them, you get total area equals 2. Okay, so you can calculate the area without using the determinant formula. So the determinant formula only used when your triangle is positioned irregularly, okay, or the shape is not regular. So you need to use this uh, matrix formula. And then for this x minus 1 here, there's another formula you need to find, which is alpha, beta, and gamma. So for now, just take note of this formula. Okay, later on we will see an example on how to apply this formula. But for now, just ambil je dulu. Okay. So we use the x minus 1 here and substitute this x into equation number 5, this one. So we get the relationship between A and the displacement. So the A1, A2, A3, A4, A5, A6 are used to in here, okay, in the displacement function A1, A2, A3, A4, A5, and A6. And again, we derive the displacement function here. Okay, there are so many derivations that I think will be just too much, so I skip. So this is one of the important formula later we will use. Okay, so the strain equals B times the displacement. So this relationship 29 here relates the strain and the displacement of each node. Okay, so the matrix B is given here. Okay, B is BI, column BI, column BJ, and column BM. So BI, BJ, and BM is given here. So this three formula you need to jot down. Okay, later on we will see an example how to use this formula. So this is to find strain. So to find strain, we use matrix B times vector D, vector of the displacement. And to find the stress, so for plane strain, you use the formula that I showed earlier. So sigma equals D times strain. Okay, so D is your stiffness matrix of the element, and E you can obtain here. E equals B times D. So for plane strain, D equals the one that I showed earlier. This one. This is the D for plane stress condition. Later on, the question will give either plane stress or plane strain. So you use D according to what question ask you. Okay, so this is about finding sigma and epsilon, or strain and stress. But your constant strain triangle also have stiffness metric or element stiffness metric similar to truss element and beam element. So this is the derivation which is okay, macam malas nak explain panjang sangat. So we go straight to the formula for stiffness matrix. K equals T times A times B transpose times D. So this is D is the D previously times B. So T is the thickness of the element. Okay, so D is the thickness of element, and A is the area of the triangle. And B is the one that I shown earlier. And BT, you need to transpose the matrix B that you obtained earlier. So you need to know what is transpose. Basically, pusingkan dia, okay? Later, we will see an example how to calculate K. So this K, later, maybe next week, I will show you how we can use this K when there are more than one triangle. So we can superpose this K similar to the K in truss element and also in beam element. But for constant strain triangle, when you superpose K, then the global stiffness will be much bigger compared to thrust element and beam element, because here if you see for one triangular element, constant strain triangle, the K is already 3 by 3. So imagine if there are 3 triangle that is connected together, then the K global K matrix will be more than maybe 6 by 6 or 7 by 7, will be much bigger. Okay, so this is about constant strain triangle. There are so many derivation, but I don't think if I explain the derivation, it will make you understand. Okay, it will make you sleepy even. Okay, not understand. So let's recap on what the formula that you need to know. Okay, you need to remember on CST topic. So the first formula that you need to remember is this three: principal stress and principal angle. So this formula you have found already in strength of materials. So I think if you tak fail strength of materials, you remember this formula. And then the next formula is the D. So D for plane stress is this one, and D for plane strain is this one. Okay. So depends on what the question wants. If the question says plane strain, so you use this D. But I think most of the time the question will say plane stress. Okay, because plane stress are used for a very thin element. Okay, so this is the D for plane stress. And then if you use constant strain triangle, we need to know the naming convention. So we start we name the nodes on the triangle counterclockwise. Okay, so if you put the left side, the most left element as number one, then follow counterclockwise. The next one will be number two and number three. Okay, so we put the leftmost element or node at leftmost node as the first node. Okay, or node number I. And then each node has displacement U and V. So U is the X direction displacement and V is the Y direction displacement of each node. And then the formula to calculate to calculate B. Okay, so to calculate B, these are the formula. So BI equals 1 over 2A beta gamma. So there are beta and gamma here. So beta and gamma, you can calculate it from this formula. Okay, so this is the beta and gamma. So beta and gamma depends on the coordinate of the triangle. So beta I, for example, equals coordinate y of j minus coordinate y of m, and so on. So this you need to remember to get beta and gamma. So beta and gamma later on will be used to calculate matrix B. And then matrix B will be used to calculate the strain. Okay, so strain equals B times D. And first you need to construct B. So B has 3 columns, BI, BJ, and BM. So the columns are this 2 by 3, 3 by 2, okay, 3 by 2 matrix. Okay, so later on your B will have a 6 column, 3 rows times 6 column. So after you obtain a strain, you can calculate the stress using the stress-strain relationship. Or you can calculate stress from the displacement using this formula, dB displacement. So again, it comes from this formula. And then you can also calculate the stiffness matrix of the constant strain triangle using this formula for constant strain triangle, the stiffness matrix for CST, constant strain triangle. So K equals T times A. So T is the thickness, A is the area, and B transpose times D times B. Okay, so banyak formula. Harap bertenang. Now let's look at an example of how we can apply this all of this formula to calculate constant strain triangle element. So question A, evaluate the stiffness matrix for this 3 CST element. Oh, sorry, only one. Okay, so only maybe for the CST element given here. Assume plane stress. So here the question say plane stress. So we know that we need to use which D, okay? And then given E, the Young modulus is 210 gigapascal and the Poisson ratio is 0.25. And the thickness of this element is 1 cm. Okay, so let's look at how we can calculate this. Okay, so let me draw first. Okay. Okay, so the first thing that we need, the question asks is to evaluate the stiffness matrix. Okay, so the stiffness matrix is given by this formula here. K TAB transpose DB. So let's jot down K T A B transpose DB. So to find K, we need to have A, we need to have T. T is already given. A, B, matrix B, and then we transpose the matrix B, and we need our D. So D is for plane stress D. So let's find A first. So T is already given. So we need our A. So assume everything is measured in cm, I think. Okay, so assume cm. Okay, cm. So this is a segitiga tegak. In English apa dah? Okay, so this is a regular triangle that you can calculate the area straight away without using the matrix formula. So to calculate the triangle, the area, so area equals. So if you look at one side, this side, so half times the length is 2, and the height is 2. The height is 1, sorry. And then we have two triangle, similar triangle. So we times 2. So the area will be 2 cm squared. Okay, so you get 1 marks if you calculate the area. Then we can assemble our matrix B. So we need to go back to B, the formula for matrix B. So the formula for matrix B is this, but we have to find beta and gamma. Okay. So first we need to find beta and gamma. So beta and gamma can be found using this formula. So beta I equals yj minus ym and so on. Okay. So if you remember only one, I think you can remember the rest. So beta I, j minus m, gamma I, m minus j. Okay, so beta represent y, gamma represent x. Tak tahulah macam mana. Tapi exam kan online. So you can just refer lecture notes. Okay. So yj minus ym, xm minus xj. So let's calculate. So beta I equals yj minus ym and gamma I equals xm minus xj. So we go back to our figure here. So we need to name the figure using the counterclockwise convention. So again, we start with the leftmost. So node number 1 will be I, node number 2 is J, and node number 3 is M. So now we can calculate beta and gamma. So beta I equals, so Yj, so Yj is 0, Ym is 1. So beta I equals minus 1. And then gamma I equals xm, xm is 2, xm is 0, xj is 2. So gamma I equals minus 2. Okay, so you just repeat the process. Then we calculate beta j. So beta j is ym minus yi. And gamma j equals xi minus xm. So beta j equals ym. Ym is 1 minus yi is minus 1. So you get 2. Xi is 0. Xm is 0. Okay, xi 0, xm 0. So you get 0. And we repeat for beta m. So beta m equals y I minus yj, gamma m equals xj minus xi. So beta m, yi minus 1 minus yj 0. So you get minus 1. And then gamma m, xj 2 minus xi 0. So you get 2. So now you get beta and gamma. Now we assemble into the B matrix. So the B matrix equals 1 over 2a times times this one. Okay, so let's copy first. So times beta I 0 gamma I 0 gamma I beta I, then repeat. Okay, so you substitute into the B matrix all of the beta and gamma. So 1 over 2A. So A is 2 cm. So you get 1 over 4 times minus 1, 0, minus 2, 0, minus 2, minus 1. And then 2, 0, 0, 0, 0, 2. And then minus 1, 0, 2, 0, 2, minus 1. Okay, so this is the matrix B. And then to find K, we need to transpose this matrix B. So we need to transpose. So just transpose, you get 1 over 4 times pusingkan dia. Sekejap pening. So pusingkan dia, flip it over, transpose again. So you get minus 1, 0, minus 2, 0, minus 2, minus 1, 2, 2, 0, 0, 0, 0, 2, minus 1, 0, 2, 0, 2, minus 1. Okay, so you just transpose this matrix B. Then after that, we can find our K using this formula K that equals TAB transpose DB. So first we need to find our D. We don't have our D. So D for plane stress equals E over 1 minus V squared times one minus V over 2. So you get 1 V. Okay, so you find your matrix D. So it's equal, E is 210 gigapascal. V is 0.25. So substitute first. So you get 224 times 1, 0.25, 0.25, 1, 0, 0, 0, 0, 0.75 over 2. Zero 0.375. Okay, so you have matrix D and matrix B. So to find K, just use this formula, okay? Dia terlalu besar. So you can calculate using calculator, okay? So try to simplify. You will get a 6 by 6 matrix. Okay, so this is 6 2 3 by 6 by 2 6 by 3, sorry, 6 by 3, 3 by 3, and this is 3 by 6. So you will end up a 6 by 6 matrix. Okay, so don't calculate manually, so use your calculator. Okay, so you can create matrix in calculator and try to calculate using calculator. Okay, don't calculate manually. Okay, so this is how you can obtain matrix K. So find all of this one by one. So find T first, and then A, and then B. So to find B, you need to find beta and gamma. So beta and gamma, basically you need to refer to the coordinates of the triangle. And then after that, you can find the matrix D. So usually it's a plane stress. So use the formula for plane stress. So after you find B, you need to transpose B. Sorry, you need to transpose B first. So transpose, make sure you flip the matrix over. Okay, so flip dia. Tak tahu macam mana nak explain the flip. So when you flip, you can get B transpose. And then after you get everything, So you just plug in into this formula. So you will end up a 6x6 matrix. Okay, so for one element of CST, it's a 6x6 matrix of the stiffness element matrix. And now let's go to the next question B. So question B, determine the element stresses. Determine the element stresses sigma x, sigma y, and tau xy, the principal stresses, and the principal angle. So the nodal displacement are given here. So let's jot down the nodal displacement first. So the nodal displacement equals 0, 0.0625, 0.03, 0.0625. Okay, so to find the stress, first you need to find the strain. Okay, always find the strain first. So the strain formula is this one. Strain equals B times D. Okay, so boleh kira sendirilah sebab saya malas. So strain equals B times D. So you can calculate this. And then after you found your strain, then you can just use this formula to find the stresses. Okay, so to find the stresses, so it's equal D times strain. Okay. And then after that, you can use this formula for principal stress and principal strain. Okay, so you have your x, sigma x and sigma y, and also tau xy. So you can use this to obtain the principal stresses and principal angle. Okay, so that's about it for CST. Any question before we end this lecture? Okay, so if you don't have any question, I want to give you one quiz or assignment, okay, that you need to submit next week. So evaluate the stiffness matrix for this triangle, triangle A and triangle B. So similar, assume plane stress condition. Given E is 210 gigapascal and V is 0.25 and the thickness is 1 cm. And then determine the element stresses, principal stresses, and principal angle. Okay, so the nodal displacement, assume similar to this one. Okay. So the reason why I give you this is for you to practice. Okay. So your test later, I think it's will be on week 13. So please do this and submit next week, and we will discuss this. Okay. So now is week 10. So we only have 2 more weeks to uh, do some revision. Okay. So please do this so that you don't study last minute. Okay. Because test 2 is 35% and it requires a very long calculations, okay, when involve CST, trusses, and beam element. The calculation will be very, very long and you might tak sempat jawab, okay. So please jangan main-main untuk test 2. Okay, so if you don't have any question, then see you next week. InsyaAllah. Assalamualaikum. Goodbye.
Thank you, Zul.
Okay.
Thank you, sir. Waalaikumsalam.